Hi, people. I was getting a pencil. Uh-huh. All right, so what? Today's Thursday, right? 24th? It's a B-Day. B-Days are back. All right. It really helps also if I turn the screen on. Okay. So today is going to be all about that fourth and final formula from that table. Okay? Again, if you watched the videos from yesterday, which I hope you did, but there was a comment that was made and that I kind of reinforced was that for those formulas that we were working on yesterday, those kind of middle two, if a situation presents itself that you have to solve for, like one of the questions is solve for the final velocity, solve that one and then use the much shorter and maybe simpler formula that we learned the first day. The VI plus VF times delta T, okay? That may be simpler than using the third equation from yesterday. So that's what's kind of neat about physics, is that a lot of the formulas can be kind of intermingled, intertwined. I'm trying to say intertwingled. That's not a word, or it could be. But there's a lot of connectivity between formulas and scenarios in which you're given certain values. Okay, so again, it is completely fine with me if you decide to use a different formula given the information and it still works. What's the difference, right? And when we start talking about chapter 3, when we get into vectors, you're going to find that depending on which point of view you take, your answer is going to be different, but it'll still be right. You can have more than one correct answer. It's all about how you phrase your answer, okay? So we'll talk about that a little bit later on. All right, so we're going to hop right into the problem here, okay? So we have a problem of dealing with final velocity after any displacement. And so this is going to be, again, referencing that fourth formula. So we have a person who is pushing a stroller, starts from rest, uniformly accelerates at a rate of 0.500 meters per second squared. What is the velocity of the stroller after it has traveled 4.75 meters? So what we know is that we have a displacement, we have an acceleration, and technically we have an initial velocity. And we are trying to find the final velocity. So given those parameters, we're not solving for anything else. We're going to use that fourth equation, the fourth formula here, okay? Now, before we get into the solving of the problem, one thing that you might find convenient, as they say here, is to start thinking about coordinate systems, okay? Especially when we get into chapter 3, coordinate systems are going to be very important. Basically, all it is something like I drew the other day, a big cross there, big plus sign, just to indicate directions, okay, and what's positive and what's negative. Okay, anything typically to the right or the east or up or north, that is considered to be positive. Anything down, south, left, west, if there's any ones, are considered to be negative. And again, when we are talking about vectors and displacement, when we see positive and negative values, that is really indicative of direction. Not necessarily value, but direction. It describes direction of velocity, describes direction of acceleration. Okay, so that's why these are important. So the formula that we're going to be using today is that last one, like I mentioned a couple times. VF squared is equal to VI squared plus 2A delta X. Okay? So, remember though, It's very important to remember this fact. When you are solving for, well, either in this case, either the initial velocity or the final velocity, you notice they both are squared. Make sure to take the square root of both sides so it's just the variable by itself. Okay, if you don't do that, your answer is not going to be correct. All right? So, plugging in what we know, what we were given. Again, we knew that it started from rest, that it accelerated uniformly at a rate of 0.50 meters per second squared, and it covered a distance of 4.75. And so after we've done all that, you notice we've got the plus or minus signs here. Okay? That is indicative, again, of the direction. So you get an answer of plus 2.18 meters per second. But now is when the time comes that we really need to focus on replacing, did not see that there, replacing that plus sign with the direction. And oftentimes, I guess I can't. Oftentimes, I have to erase that. What? All right, I'm new at this. Oftentimes, if we go back and we can reread the question to see if it tells us the direction. But again, for this particular question, it did not. But it did recommend that we set up a coordinate system. I'm the person who always just assumes that, everybody's going in the positive direction. Oh, that's such a life lesson too, right? So again, if we assume that the person is making the decision to go to the right, and our calculation is still a positive, then that person is going to the right, okay? Let's do another example. I need you to open up your books to page 58. Just kidding. Page 58. Hey. Yep. I can't find. There it is. Oh, there's my pen. Yay. All right. Once I get my book open. And since we've been spending so long on these formulas, and they all have a relative similarity to each other, I just want to focus on one question. Okay? That's going to be question 4. So question 4 on page 58. Can't get my camera right. All right. There we go. It says a motorboat accelerates uniformly from a velocity of 6.5 meters per second to the west to a velocity of 1.5 meters per second to the west. If its acceleration was 2.7 meters per second to the east, how far did it travel during the acceleration? Lots of interesting wording going on there, wouldn't you say? Talks about initial velocity and a final velocity going west, but acceleration going to the east. Bingo. It is slowing down. So anytime an object is slowing down, the acceleration is to be considered going in the opposite direction of the motion of the object. That's why the acceleration is to the east, 180 degrees from its motion. So very good. So let's again write what we know. Okay. Excuse me. So we know our VI, 6.5 meters per second. We know our VF, which was 1.5 meters per second. And we know our acceleration is 2.7 meters per second squared. Okay, so since we only know these 3 variables, Question? Okay. Since we only know these three variables, we have to use the formula, the last one, okay, to where it's VF squared is equal to VI squared plus 2A delta X. And the real reason why we have to use this particular formula is we know nothing about time. Okay? There's no time variable listed, but net. Time variable listed. So, that's why we have to use this formula. But we are going to need to rearrange this formula to solve for x. So how do you want to do this? What's the first step you want to do? Okay, subtract vi. So you're going to get vf squared minus vi squared equal to 2a delta x. What next? Divided by 2a. So then we get delta x. Sorry, I like writing my single stuff on the left-hand side. Vf squared minus vi squared is going to be equal to 2a. All right, now that we've got it rearranged, let's go ahead and plug in our values here. So again, Vf is 1.5 meters per second, and that's squared, don't forget, minus Vi, 6.5 meters per second squared, divided by 2 times 2.7 meters per second squared. So, you already got it back there? What do you got? And what unit is it? Okay. So negative 7.4. But let's put that in terms of a direction. Because we got this sign there. Left or, did you say west? Sound like you said. Sorry, my bad. My bad. 7.4 meters west. So again, you want to try to do your best at providing a direction when possible. Okay? And not including that sign in your final answer. Okay? Because again, yes, as physicists now, that you'll probably see those numbers and hopefully eventually start to think of, okay, that means direction when we're talking about this stuff. But for the casual reader, we want to let them know that that sign is actually indicative of a direction. Okay? And we'll do that by replacing it with the direction itself. Okay? Questions? Okay. Like I said, we've been doing this work all week. I'm going to call this video done. And once I get this video done, I will get it posted and then also post along with it Problem Bank E. So just give me a few moments and I will get that going.